Now that we have the minor parts out of the way, we can work on some more interesting mechanics. The first one is going to be multiple weapons. Inside of the actual game, the player should have 3 different weapons: a gun, a shotgun, and a rocket launcher. Each of those gets different bullets and animations, all of which we have to manage. On top of that, the player can toggle between them. For all of that, inside of Godot, I need to find some kind of way to manage all the data. I think the easiest way of doing that is to, number 1, add a new folder for, let's call this one Global, in which I want to create a new script that I called data. Click on create with all of the defaults, and then you have data.gd. In here, I want to store all of the data, and this should be available everywhere, which means inside of project, project settings, and globals, I want to select the script, so global data.gd, and then add it as a global. That way, inside of the entire game, we always have this node available. Or in other words, if you run the game, you can go to remote, and there we have data, besides the actual game. We are going to store a bit more data in here later on. But for now, I want to add an enum gun, which is going to be an enum dictionary where we can specify the different guns. I want to have a gun called single, shot, gun, and finally, let's call this one rocket. Now, in case this looks weird to you, enums in Godot are a way to organize specific values. The way you would use them. Since data is global, we can work in here, and when the player is ready, I want to, for example, print data, then we have gun, and if you now press dot, you get the 3 different options, which is a really nice way to avoid typos, which is kind of the main purpose of an enum. Although, if I print this value, we are going to get 0. There you can see it, 0. Internally in Godot, enums are basically integers. The value for single would be 0, for shotgun would be 1, and for rocket it would be 2, which is fine for our purposes. All that we really care about is that we get a value like this that is super readable. Readability is basically the main purpose of an enum. It's basically a system to make sure that you can work with your data and the entire thing is readable. Let's actually use it. I think that's the best way to learn about them. I want to have a mechanic so that we can toggle between these different weapon types, for which, instead of project, project settings, and the input map, I want to have a new action, which I called simply toggle. You could call it gun toggle, it doesn't really matter. In there, I want to add some input, and now we need keyboard and controller input. On the keyboard, I have used the E key. For the controller, I have used the B button. If you have your own controller, just choose what you think feels right. If you don't have a controller, don't worry about this part at all. You can skip it entirely. All you really need is some kind of binding, so you can trigger this toggle action. After you have that, inside of player, under get input, I can minimize all of this again. And then I want to check for if input is action just pressed with toggle. This one here. If that is the case, I want to update a current gun value, which at the moment does not exist. So once again, all the way at the top, I want to have a var current underscore gun. The data type for this is going to be data.gun. That way, we only allow enums of this type for this variable. And for now, the value that we want to assign is going to be the current gun plus 1, which is going to look weird. But remember, enums inside of Godot are just integers, so you can add them inside of math formulas. If we print the result, current gun, and run the game, you are going to see the result. If I press E, we're getting 1, because the operation we did was 0 plus 1. If I do it again, we get 2, and this I can do over and over again. Once again, remember, enums are just integers that are a lot more readable. That's fundamentally all that they are. So this system would work to change the enum, but we have to modify it a bit because we only want to have the enums 0, 1, and 2. If we're going beyond that, we want to start from the beginning again. In other words, we want to go from 0, 1, 2, back to 0, and continue with 1 and 2, and do this forever, every time we trigger this action. The function to make that work is called posMod. We are getting the mod, and the mod always has to be positive, where we are getting the current gun plus 1, and then for the size, the maximum value, we want to have data.gun.size. If I now try the entire thing again, I can press E, and we're getting 120, 120, and so on. We are always staying within the confines of this dictionary. And if you want Godot to stop complaining, you can define this value as data.gun. posMod will return an integer, and via sData.gun, we are turning it back into an enum. As a consequence, we are getting a proper enum for our current gun, and we can toggle between it via one line of code. Pretty nice. Now we have to use it. And for that, we have to do two things. Number one, inside of the player animation, we want to select the right torso depending on the selected gun. In other words, if I show the player and go to graphics and characters, there we have player.png, which contains all of the player graphics. At the moment, for the torso, we are only using the first row. The second row would be for the shotgun, and the third one would be for the rocket launcher. Other than that, they have the exact same system, where the first one is pointing to the right. You can see it here and here. The second one is going down and right. The third one is just going down, and so on. Which effectively means, for the player, when we're getting the torso, we have to decide if we are on the first, second, or third row of the animation. And that we can get quite easily, because remember, these values are just integers, and they are 0, 1, and 2. That we can convert super easily to pick one value from the torso sprite frames. All we have to do, when we are selecting the frame of the player, at the moment, we're getting gun directions and adjusted direction. Via that, we have this dictionary where we are picking the direction depending on where we are aiming, and we are always on the first row. Or to be a bit more specific, we are on the row with the index 0. That's the default. But if we are using a shotgun, then I want this to be a value of 1, which we can get by adding the integer of the current gun. This would be a value that's either 0, 1, or 2. And this I want to multiply to stay in the same column by torso sprite dot h frames. That's all we needed. If I now run this thing again, I can press E, we're getting the shotgun, I can press E again, we are getting the bazooka, and E again, we are back to the default gun. This also works while I'm ducking, while I'm jumping. It works really well. With that, we can toggle between different guns, and that's pretty much it. And once again, enums are incredibly useful to organize your data, but fundamentally, we are just working with different integers. When you're getting started with them, they can feel a bit overwhelming, but if you are using them for a bit, you will notice how useful they are. Definitely practice them. For a more complex game, they are essential. Now that we have multiple guns, I also want to have multiple bullets. Which means, once again, we have a basic gun, shotgun, and rocket launcher. The basic gun just shoots bullets. That we already have. The shotgun is going to get particle effects. The rocket launcher is going to shoot bigger bullets that explode on impact, for which we already have a lot of basic stuff. Let's start there. Back inside of Godot, in the player script, when the player presses inside of get input and shoot, we are emitting a signal where we are getting the current position of the player and the aiming direction. I want to emit one more signal, which is going to be the current gun. Although for that to work, inside of the signal for shoot, we will need one more parameter. Let's call it the gun underscore type. For the data, we will need data.gun. After that, inside of the level, when we have onPlayer shoot, we want to have the gun type of type data.gun. And for now, let's simply print it gun type to check if this is working. If I now shoot, we get 0, 1, and 2, and back to 0. This works pretty well. That means, next up, when we are setting up the bullet, I want to pass in the gun type, so the bullet knows what it's supposed to be. Next up then, we have to work inside of bullet.gd, and the setup function will need the gun type parameter. Once again, data.gun. This for now, I want to store inside of a variable, var type, once again, data.gun, and then inside of the setup function, I want to update the type to be the gun type. That way the bullet knows what it needs to do. So if we are shooting a rocket from the rocket launcher, then on impact, it should create an explosion. But before we get to that, inside of fire, in the graphics, we have a default bullet and a large.png bullet. This we want to show when we are using a rocket. As a consequence, inside of this script, I want to create another const. This one is going to be, let's just call it texture for the bullet. The values are going to be data gun dot single, for which we want to preload the default.png file inside of PNG. Then duplicate the entire value, because next up we want to have the rocket launcher. The graphic for this one is called large.png inside of the same folder. We do not need a shotgun bit in here because the shotgun logic is going to work differently. That we will work on next. All I care about for now is that when we're calling the setup function, I want to override the value of, let me open the bullet.tscn. Inside of this sprite2d, at the moment, we have the basic bullet. But if we have a rocket, then we want to have large.png as the texture. To get that, inside of sprite2d, I want to update the texture, and the value is going to be texture, the constant we have just created. And on there, we can use indexing with the gun type. And that is pretty much it. If I now run the entire thing again, I can still shoot individual bullets. That works. And if I use the rocket launcher, we're getting much bigger bullets. I guess now they would be projectiles, but you get the idea. That covers the look of the bullet. Besides that, once there's a collision, which we can check via onBodyEntered, then we want to trigger an actual explosion, for which we need a signal. Signal explode, with one parameter, a position. This has to be a vector2, which we want to emit when there's a collision inside of this function, and this should only happen if we have a rocket. Or in other words, if type is equal to data.gun.rocket. If that is the case, I want to explode.emit with the current position of this projectile. That should cover the basic logic, although we have to connect this signal first of all. Inside of level, when we are creating a bullet, this one here, we have to connect the signal. I want to have bullet connect. The signal is called explode. This one here. And this we want to connect to a function. And now, what is really nice, when a drone explodes, it is creating an explosion that we can reuse. I simply want to call create explosion, and then we are pretty much done. The actual explosion is what we're creating in all of this. So if I now run the scene and I use the rocket launcher, I can shoot at things and we are getting an explosion. And if I shoot at a drone, after 3 hits, it should disappear. Actually, 2 hits are enough. And there we go. This is a rocket launcher that is pretty nice. I can also hurt myself. That does make sense. So now we have a really neat effect. And just in case you forgot, in part 1, for the drone logic, once a drone connects with a player, we are getting an explosion, which is done via all of this and an explosion.tscn scene. This we are reusing for the bullet. Besides the rocket launcher, we need the shotgun logic. This one is going to be quite different. We are not going to create a bullet. Instead, we will create particles. That means inside of the player, I want to have a GPU particles 2D node that I suppose we can rename to shotgun particles. For which, let me zoom in just a bit. We first of all need a couple of things. Most importantly, a material. If you go to process material, there you can add a particle process material. And once you have that, you get some very basic particles. A good start, but not exactly ideal for our purposes. Also, for shotgun, this should be, inside of time, a one-shot node. That way, via emit, I am only shooting a specific amount of particles one time. Now we are going to make all of this look really nice in just a bit. First of all though, I want to actually make it do something. Which means, when we are shooting, I want to check if the current gun is data.gun.shotgun. And I hope at this point you start to appreciate enums. Via those, it's really easy to get a distinct value and not have typos. Most importantly, I want to get the shotgun particles and set emitting to true. This is going to do something, although it's going to look terrible and probably cause an error. Let's try. If I now shoot with the shotgun, we're getting an error message that inside of the bullet, so we are in bullet.gd, we don't have a value inside of this texture. And that does make sense. There's no shotgun in here. That is totally fine, because when I am shooting a bullet, I only want to create a bullet if the gun type is different from data.gun.shotgun. Like so. Only then do we want to do all of this. And in just a bit, when we have the else statement, meaning we do have a shotgun, then I want to do something else. For now, I just want to have pass. Next attempt. If I now shoot with the shotgun, we are getting a super weird effect. I guess at the very least for now, the game doesn't crash. Now there's one thing that we absolutely have to change. Inside of the shotgun particles, we want to update the process material. In there, we can set a direction, which is going to be the direction that we want to shoot in, which once again, we can get from get aim direction. Although for that to work properly, inside of the shotgun particles, we have to make sure that we don't add any kind of gravity. Let me drag this one out a bit. Inside of the GPU particles, you want to look at the process material, expand this one, and then inside of acceleration, we have gravity. Our bullets are not supposed to have any gravity. That way, if I'm spawning them, you can see one dot here in the middle that disappears. We are spawning a whole bunch of particles, the particles don't move, and then they disappear. That's all that's happening at the moment. That also means inside of the game, if I'm shooting with the shotgun, we are getting a dot that disappears. I guess that's some kind of start. To make this effect better, inside of spawn, we have a velocity. And there we can set an initial velocity, which I want to be between 200 and 280. That should already do a bit. If I now shoot with the shotgun, we are getting something. So I guess at least we are shooting vaguely in the right direction. To make all of this look better, we want to have a texture, for which you want to go to Graphics, and there we have Shotgun Explosion. This is a basic explosion that looks like this, a simple frame animation. This you want to play for every single particle. And let me get rid of the sprite 2D. Inside of Shotgun Particles, to attach this animation, you first of all have to go down to Material. You want to set this to Canvas Item Material, in which you can activate Particle Animation. In our case, we have 7 H-frames and 1 V-frame. This is what we need in here. Once you have that, you can go all the way to the top and set a texture. We want to use the Shotgun Explosion. And now, if I do that, we're getting a more interesting effect. And just to demonstrate, if you hadn't set this Canvas Item Material and you tried the entire thing, you would get the entire texture. So not great. You do want to have the Canvas Item Material with Particle Animation and 7 frames. A much nicer effect. This you can also animate. Under Display, we have Animation, in which I have set a speed between 0.3 and 2. With that, inside of the game, if I now shoot with the shotgun, we are definitely making progress. Another important thing that we have to change is inside of time, the duration of this animation should be 0.3, and the amount of particles should be 20. Next attempt. If I now shoot once again, we are getting a much better effect. This shouldn't start from the center of the player. It should start with a bit of an offset. For that, once again, I want to get the shotgun particles and set the position, for which I simply want to get the aim direction once again, and then multiply it with some kind of value. I think earlier we have set a crosshair distance down there. Besides that, we can export a var shotgun distance, which I want to be, let's say 30. This we want to use down here, shotgun distance. Next attempt. If I now shoot, probably has to be a bit further away, but fundamentally, this works reasonably well. As always, you can refine things a lot. When you're working with GPU particles, you have a huge amount of options. As always, just play around and see what you like. In my case though, I want to make sure that this actually hurts the enemies, for which we want to work inside of the level. Instead of creating a bullet, I want to check if the enemy is vaguely inside of my aiming direction. For which, first of all, we need to get all of the drones. For drone in get free, get nodes in group drones. And as a reminder, if I open drone.tscn, there we have the drone inside of the group drones. And now inside of the level, when we are shooting with the shotgun, we are getting all of them. And now we have to calculate if the angle from the player to the enemy is the same or at least very similar to the aiming direction. Which means I want to have a var bullet angle, or I guess this should rather be the aim angle. And besides that, I want to have var enemy underscore angle. If those two values are vaguely similar, then the shotgun should hit the enemy. For the aim angle, I simply want to get the direction, the one that we're getting from the parameters. And on there, we can simply get an angle. And to make the math a bit easier, I want to convert this from radians to degrees. You don't have to do that part. I think it's just easier to understand. Besides that, we need to have the angle from the player to the enemy. That we can do via drone.bullet position minus the position of the player. Or to be a bit more specific, the starting position of the shot. This, once again, is going to be a vector, so on there we can get the angle. And like for the aim angle, this we want to convert to degrees, so rad to degree. Now we have two angles that we want to compare, which simply means if the absolute value of the aim angle minus the enemy angle is below 90, then we know the enemy is vaguely inside of the right direction. If you make this value smaller, then the shotgun cone is going to be smaller. Also, what we should really check is if the enemy is close in the first place. For that, we can simply check the position distance to with drone.position. Only if all of that is the case, then I want to get drone.hit. And with that, we should be good to go. And I guess for testing purposes, inside of the drone, when the player enters it, I want to comment out this line, and for now, simply add pass. That way, the drone will not activate. That should make testing a lot easier. So now, we can test this if statement. And I realized I forgot that this should be if the position and distance to the drone position should be smaller than some kind of value. I have set this value to 100. If we now try the whole thing, with the shotgun selected, I can be next to this drone, shoot in this direction, and nothing is going to happen. Same down here, but if I now shoot at the drone, we get the drone was hit. If I do this 3 times, then the drone is going to explode. And that is pretty much it. With that, inside of the drone, we can reactivate the enemy and get rid of this print statement. With that, we have the shotgun.